Okay, this can be confusing as to what's going on, so hold your horses here. A scientist wants to make 6 milliliters of a 30% sulfuric acid solution. The solution needs to be made from a combination of 20% sulfuric acid solution and a 50% sulfuric acid solution. How many milliliters of each solution must be combined to make a 30% solution? So I know what you're wondering. What in the heck did I just read? Well, here's a picture of what's happening. Don't try to draw it, okay? You got this container. It's a concentration. The black crap is the sulfuric acid, okay? There's 20% of that. The rest of the container is water. The reason it's 80 is because 20 and 80 makes 100, okay? Then I have another container. The black crap is the sulfuric acid, 50%, okay? And then 50% of it's water. We need to dump them in the same bucket. The bucket needs to have 6 milliliters. And when I'm done dumping it, I need 30% of the black stuff, sulfuric acid, and then the other 70% is water. Now, we also know we need 6 milliliters in this bucket. How many milliliters do I need to dump from each bucket to get 6 milliliters? Okay. Don't draw that. There's a way to set this up. You gotta listen. So you're finding the milliliters from the 20% bucket and the milliliters from the 50% bucket. So ml at 20%, ml at 50%. Here's what you're going to do first. You're going to go up above the problem, okay, or up top. Whether you have up above, if you have the packet up above the problem, if you got a paper up here. Write down your lowest percent, and then write of. Then move over here. We'll fill in the of here in a bit. Now don't go to your highest percent. Remember, it's lowest combined with highest equals somewhere in between. Now go to your highest, 50% of, and then go to the middle. You go low, high, middle. Lowest percent, highest percent, middle percent. Now, this last one, you have the value for the of, because it says it's 6 milliliters of a 30%. So 30% of 6. And then 20% of X and 50% of Y, because we don't have either one of those. That's what we're trying to figure out. How much comes from here, how much comes from here. And that's always how it's going to be set up. Now, leave that off and make a table. Okay? You're going to make the table, but you're not going to label it. You don't have to label these. Now, up top, you're going to put your 3%, but we need to write them in decimal form. Okay? That means move the decimal twice to the right. So 0.20 times X. Okay? 0.50 times Y. 0.30 times 6. Okay. Okay. So and that's going to be the standard on all these percent mixture problems. Now here's what you put in the top three. Just put 0.20, 0.50, and 0.30. Then the second row, you're going to put X, Y, and 6. Then you're going to multiply. 0.20 times X is just, you can put the 1 if you want, it's 0.20X, okay? 20% of X. 0.50 times Y is 0.50Y. And then 0.50 times 6, I can actually figure that out. There's no variable. 0.30 times 6, my bad. 1.8. Okay, now you have to solve for x and y. Now you have two equations, okay? The x plus y equals 6, and then this times x, and 1.8. So you're going to make your cross, and you're going to write x plus y equals 6. Then I'm not a fan of having this as decimals, so here's how you can eliminate the decimals. You can times all of these by 100, because then the decimal can go away, okay? So before I write the second one down, I'm going to take 100 times 0.20x, and that's 20x. Then I take 100 times 0.50y, and that's 50y, equals, and you got to take your 1.8 times 100. That's 180, okay? Now you're using the elimination rule. Nothing adds to 0, so get your x's the same. So you have 20, you have 1. So the rest of this is times 20, the rest of this is times 1. Okay, so 20 times 1x is 20x, 20 times 1y is 20y, and then 20 times 6 is 120. And then the bottom is just the identity, okay? Meaning it just, all times 1 means it stays the same. Okay, if I make that a negative 20, I'll get my 0x, but then 50 goes negative, so does 180. So we take 20 plus negative 50, and I get negative 30y. And I take 120 plus negative 180, I get negative 60. Okay, 0x is eradicated, eliminated. So I got negative 30 times y equals negative 60. If I divide each side by negative 30, I get my solution for y, it's 2. So the y is 2, so the 2 is with the 50%. Now to find the x, you can just take 6 minus 2, that'll work. Or if you really have to, you can plug 2 into the first equation. 1x plus 1y equals 6, since 2 goes in for y. Okay, 1 times 2 is 2, so that's 1x plus 2 equals 6. Then you minus 2, you get 4. Then you can divide by 1, but it's still 4. Okay, so there's 4 milliliters that need to come out of that, 2 milliliters that need to come out of that, and then you end up with your 6 milliliters with the proper percentages. And that's how all these are work. I'm not going to draw pictures on every one of them. Okay, next problem. How many ounces of a 20% hydrochloric acid solution and 70% hydrochloric acid solution need to be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? So you need to find the number of ounces, and it's the same situation here, just with different numbers. Ounces at 20%, ounces at 70%. So go up here and set up your percentages. When you have more than one percentage in a problem, you want to go here. The lowest percent's 20. Then write of. Highest percent, 70%. Then write of. Then in the middle, you got 50% of. One thing I will point out, since 50 is closer to 70 than it is to 20, you're going to need more out of this container than you will out of this, okay? Okay, we have the 50%. The 20 ounces that you see come out of the 50%, okay? And then we don't know this, we don't know this. Now make those percents decimals, okay? It's going to be 0.20 of means times x. 0.70 of means times y. 0.50 of means times 20. Then leave off there, okay? Make your table. So 0.20, 0.70, and 0.50. Then x, y, and 20. Okay, now multiply those. Well, you can't do much you can put a 1 in front, but it's 0.20x. You can put a 1 in front, 0.70y. And here we can actually find that product. It's 10, okay. 50%, 20 is 10. There you go. So you have two equations for x and y. You now have a system. So we have x plus y equals 20. Then I do not like all the decimals there. It makes it a pain in the butt. So just if you times by 100, then the decimals can go away. Some of you are like, yeah, you're allowed to do that. Yeah, you can times by anything as long as you times the whole equation. Why 100? Well, because multiply it by 100 moves the decimal twice to the right, okay? And I get 20x. 70y. 100 times 10 is 1,000. Okay, we're using the elimination method. We want to get the x's the same. And 1. Okay, so 20 times 1x is 20x. 20 times 1y is 20y. 20 times 20 is 400. Then on the bottom you have 20x plus 70y equals 1,000. Okay, if you add, you'll get your 0. If you make the 20 negative, they have to be opposites. So 0x. Remember to make the 70 and the 1,000 negative. So 20 plus negative 70. Remember, you got to get the negative in there. Negative 50y. Negative 600. Divided by negative 50. Negative 600 divided by negative 50 is positive 12. So 12 comes out of the 70%. Okay. Now if you just look at this, what plus 12 is 20? Well, you could just take 20 minus 12, and it's 8. That's a quick way to get that. Or you can put 12 in for y. Doesn't matter. You get 8 either way. Just to shorten the video. Okay, a farmer needs 240 gallons of milk that is 20% butterfat. If the farmer has a combination of two milks, one that's 24% butterfat, one that's 18% butterfat, how many gallons of each type of milk does he need? Gallons at 18%. Gallons at 20%. So put your low percent, or no, yeah, wait a second, I do that right. Sorry, it shouldn't say 18% there, it should say 24%. I know how many gallons are at the 20%. I need to put 24, my bad, 24. Okay, put your low percent, then your high percent, and then your middle percent of. Okay, we know the quantity we're taking the percent of there with 20, it's 24. You don't know this, and you don't know this. So that's 0.18 times x. That would be 0.24 times y. That would be 0.20 times 24. Okay. Now just drop your stuff in. So you're going to have 0.18, 0.24, and 0.20. Okay. Then x, y, and 24. Okay, now multiply these. 0.18 times x is 0.18x. 0.24 times y is 0.24y. And then here I actually find the product, 0.20 times 24, 4.8. So see how nicely I got that organized? Okay, it's beautiful. So you got two equations right there. X plus y equals 24, and then I'm not a fan of having all these decimals, so to just remove the decimals you just times by 100. So 100 times 0.18 is 18x, 100 times 0.24 is 24y, and then 100 times 4.8 is 480. And then obviously I need to use elimination. So you got 18, and then 1. So you have to times the rest of this by 18, and the rest of this by 1. Okay, so you got 18x, 18y, 432. The bottom's going to be the same. Just maintain the same thing. 18x plus 24y equals 480 because you're just multiplying it by 1. Okay, I want to get the 0x here. I can if I just make that a negative. 18 plus negative 18 is 0x. And the rest of those have to become opposite. So 18 plus negative 24 is negative 6y. 432 plus negative 480 is negative 48. And 0x, you're gone. So divide each side by negative 6, and y equals 8. So we have 8 gallons at 24%. And then to get you can put 8 in for y, or you can just get, and if you have x here, I'll just put it in for y, okay? You can do one of two things, okay? You can just take 24 minus 8, okay? And that finds that. Or you can plug in 8 for y. Okay, so 1x plus 8 equals 24. Minus 8, you get 16. 16, same thing. Okay, next problem. In a chemistry class, you have a combination of 100% hydrochloric acid solution and 5% hydrochloric acid solution. You need 100 milliliters of 3% hydrochloric acid solution. How much of each solution should you pour into the mix? You want to know the milliliters you need at 1% and the milliliters at 5%. So your low percent, 1% of, the high percent, 5% of, and then 3% of. Okay. Okay, so we have the amount for the 3%, it's 100. Don't have that, don't have that. So move the decimal twice, you'd have to fill in that with a 0, and it'd be 0.01 times x, 0.05 times y, and 0.03 times 100. Okay, and I'll make my table. And you put 0.01, 0.05, 0.03, then what you're multiplying by is x, y, and 100. So that's just 0.01x. If you put the 1, it's the same thing. That's 0.05y. And 0.03 times 100 is 3. Okay, now you got your two equations. Actually, on this one, you could have got the answer without the table. I'll explain why here in a second. Okay. So you got x plus y equals 100, and then multiply this by 100 so the decimals can go away. 0.01 times 100 is 1. Okay. 100 times 0.05 is 5. And 100 times 3 is 300. Now, the nice thing here is I don't need to multiply, okay, because I have the same in that column. If I made it negative, I would get my 0x right there. And the 5 and the 300 go negative. 1 plus negative 5 is negative 4y. 100 plus negative 200 is negative. 100 plus negative 300 is negative 200. And then the x goes away, okay? So divide by negative 4, and y equals 50. Okay, so you got 50 of the 5%. Then x plus 50 equals 100. To find x, you could just take 100 minus 50. That's 50, okay? You could also put 50 in for y right there as well. Now, I could have got 50 and 50 right away, and the reason why I would have known that is because the low percent and the high percent, 3 is right in between 1 and 5, okay? So since the other ones, the first 3, it wasn't right in between, so you didn't know. But this one, if that percent is right exactly in between the lowest and the highest, then you can just split that into 2, divide by 2, and that could be your answer right away. But that only works very rarely. So that's why I showed the whole procedure. For extremely cold temperatures, you need a combination of 100% antifreeze solution and 50% antifreeze solution. You need 11 quarts of 70% antifreeze solution. How many quarts of each solution do we need? Quarts of 100%. And then quarts at 70%. 100% antifreeze means the container has nothing but antifreeze. It doesn't have water. Okay, that's what 100% means. The 70% means 70% of it's filled with antifreeze, and then 30% of it's water. Because 100 minus 70 is 30. Okay, so set up your lowest percent. Okay, your lowest percent's 50. Then your highest percent, obviously 100. Then those combine and they add up to your middle percent. Now we have the 70%, that's 11. We don't have this, we don't have that. So I write the expression, it's going to be 0.50 times x. Okay, this would be 1. You can put 1.00, but it's just 1, okay, times y. And 0.70 times 11. So you just put in your stuff, 0.50, 1, and 0.70. And then x, y, and 11. And then find your product, 0.50x, 1y, 0.70 times 11 is 7.7. Okay. So the equations are right here this time. X plus y equals 11, and then 0.50x plus 1y equals 7.7. Whoa, shoot. I want to multiply that by 100 to get rid of the zeros, to get rid of the decimals. 100 times 0.50 is 50x. 100 times 1y is 100y. Then 100 times 7.7 is 770. Now let's try this again. Okay. Obviously we have to multiply by 50 and by 1. So 50 times 1x is 50x. 50 times 1y is 50y. 50 times 11 is 550. Okay, then the bottom, it's just the identity property, 50x plus 100y, because you're just timesing it all by 1, so that bottom just stays the same. Negative, and those go away, okay? But then negative, negative, remember you're adding. 50 plus negative 100 is negative 50y. 550 plus negative 770 is negative 220. Divide by negative 50. So negative 220 divided by negative 50 is 4.4. So go into the y. Now that's under the 1, so that would be your 100%. And then what plus 4, look at that equation. X plus 4.4 equals 11. To get the answer quickly, you can just take 11 minus 4.4. That's 6.6. Or you can write down 1x plus 1y equals 11. Put 4.4 in for y. Got to multiply that. That would be 4.4. So we have 1x plus 4.4 equals 11. Minus 4.4 minus 4.4, that's 6.6. You can divide by 1, but it's still 6.6, okay?